Electromagnetic induction is the production of electromagnetic force across an electrical conductor due to the charge in the magnetic field. Founded by Michael Faraday, his profound inventions greatly bring technology progression during the advancement of human races. Some of his contributions can be seen today, for instance, electric generator, electric motor, transformers, and many more. Taking electric generator as an example, this invention greatly aided millions of people to act as one of the backup sources in some rural areas in the event of blackout. Inspired by him, today we're going to conduct a very simple experiment with the title electric motor. Okay, in this experiment, we use AA batteries, neodymium magnets, copper wire, and this metal clip acts as a conductor for this copper wire and two connecting wires. Ignore this part. And the basic idea is when we connect the battery to the connecting wires, the current starts to flow into the metal clip, and then the copper coil is the current starts to flow into the copper coil. And this, when the current flows into the copper coil, it cuts the magnetic flux of the neodymium magnet. So what we'll expect is the copper coil will start to turn in the result of the cutting of the magnetic flux. In this experiment, when we supply the coil with current, electromagnetic force is induced on it according to Lorentz law. Thus, the coil will start rotating with a mixture of forces such as electrical force, magnetic force, and mechanical force. The coil cuts the magnetic flux, resulting in electromagnetic force. But at one point, when the coil is perpendicular to the magnetic flux, the coil will experience a sudden zero torque. With the help of inertia, the coil can complete its rotation and thus continue cutting the magnetic flux again. And the process keeps on repeating. This simple electric motor serves as a fundamental concept in the big motors nowadays. A great example would be DC motor. It is the direct application of this simple electric motor. The coils are attached with commutator with two opposite poles of magnets at the sides, and the motor keeps on cutting the magnetic flux to have continuous torque. Throughout this experiment, this gives us a very important insight that DC motors have at least 100-year-old history in the lifespan of the mankind. Through improvisation, the DC motor today is much more efficient in terms of the rotating action. By adding more loops to the rotor whenever it is applicable to reduce the inefficiency of the DC motor. Hairdryer, elevators, fan, drills, etc. are examples of implementation of DC motors. So that's all for our simple presentation. Thank you for your undivided attention.